Welcome to tutorial 7 of this 10-part series to build a parametric coat stand and then to optimize that using some genetic solvers. I mentioned in my last tutorial that I would be jumping to the solvers, the genetic solvers next. What I'm going to do first is actually look at model graphic settings and heads-up display settings. These aren't necessary at all for the functionality of the solvers, so if you're not interested in understanding how those functions work, you're more than welcome to just jump straight along to tutorial 9 and 10, where I'll be dealing with those solvers, and you can just pick up the scripts for the model graphic settings and heads-up displays already done for you, and you won't need to build them. So anyway, for those of you who want to stay and look at model graphic settings, we're going to place dimensions and we're going to color the coats. So here we go. Right, first thing I want to do is create some random colors. So colors are defined in Grasshopper in many ways. One of the ways is to give a number between 0 and 255 3 times separated by 2 commas. So I'm going to place a panel and I'm going to write 0 space capital T 0 space 255, and that's our range of colors. And then I'm going to place a random component here, and the range is going to be what we just typed in. Then multiplication into the number. So this is a number of times we want to generate a certain random number. What we want is the number of coats or hooks, which are 12, multiplied by 3, so that we have the number of coats multiplied by 3 random numbers, each color requiring 3 numbers. The seed is going to be 0 less than 5 less than 10. And this is really, if you, the numbers aren't actually random. We can't create actually random numbers. They have to be based on something to give the appearance of being random, like a snapshot in time when you clicked on a button, for example. For this function here, if you have a seed of 5 and you apply all of the same inputs, you will get the same random inverted commas number, and that's just a way of enabling different random numbers sets. Right, I've rambled enough for that. So we want to round this, so choose round to decimal place, and we're going to choose 0. We don't want any decimal places. Move that out of the way, and then we're going to partition the list. All right. So I'll put a panel in there and look at what's coming out so far. Well, first of all, I can see that we have 36 numbers, which we expected, given that we had 12 hooks, but we do have the information stored at the wrong level, the wrong branch level. So I'm going to flatten that now, and there we go, we've got it at the right level. Partitioning this information like so, we want to partition it into 3 packs, in packs of 3. So if I put another panel in to show you what this is doing, it's bringing each index into a pack of 3 sequentially. I'm just going to simplify that. And the reason for this is that we want to have a color made up of 3 numbers. So if you choose item, list item, add in a panel, I'm going to have the first one, index 0 here. Highlight all of those 2 things, drag it, press Alt, drag it, press Alt, and we want these to be 0, 1, and 2. we're going to send this information into each of these. And what we're doing here is we are picking index 0 from the information coming in, and because it's a list with multiple branches, the index we're choosing is this 208, this 105, this 178, and so on. So if I look at that, I should get 208, 105, 178, etc. So I'm going to line them all up so you can see them being added. There we go. If you look at that first list, what we've essentially done is we've flipped the matrix, and there are other functions that will do that, but here is an example using the list item function. Now we're going to concatenate. Love that name. We can zoom in and add some more entries. So I want to have 5 up to E, and then we're going to add in a comma, // comma, plug that into B and D. And then you've guessed it, yeah, we're going to plug in the first index, second index, and the third index into this function. And what that will do is produce a list of 11 folders, each with the pieces of information that we have specified. There we go. Really, we don't need it in separate folders. We don't want it in separate folders, so let's flatten that information. Great. Now, all of this is just for our information as we are building, so let's delete that, make it a bit neater, and we can group that together. Create random colors for coats. Wonderful. Now we're going to apply those colors. So if you select Boolean toggle, we're going to name this toggle by right-clicking on it and typing in show least stable condition. Right. And then we're going to have a stream gate here. Not a steam gate, stream gate, stream filter. I apologize, I do get the names of these wrong quite often. But the solution is correct. Custom preview. So whatever information we allow to pass through, we're going to apply the colors that we've just created. Great. All we now need is the information to plug in. So if we're showing the least stable condition, and this is true, which it is, then 1 will be passed through. The least stable condition we produced up here, and it's partition A. The fully loaded condition, which will be 0, and that is the timber, no, it's the coats, isn't it? Yeah, so the coat geometry, that's going to be here. So now if we choose false, it'll be fully loaded. True, it isn't. There we are. And I can hide that. So we can group this together and name that display partial loading ? Right, so the last piece in the puzzle for our model graphic settings is going to be the overall dimensions. So union box, called bounding box, bounding box. And we want to produce a bounding box over everything that we've created and place dimensions on it. So if we right click in the middle, we can change it from being a bounding box per element to a union box. So it will bound every single item that comes in. And that will be this gate 2. There we are. You can see that we've got a bounding box around everything now. And I'm going to flatten that input. Brep edges. So we're going to take the box, plug it into Brep edges, and then we're going to take the interior lines, selecting them using a list item again, internal edges, into list item, and I've already worked out what these are. They are index 0, 1, and 8. Now when we create a multi-line list in a panel, we need to right click and select multi-line data. It is a bit deceptive. For some reason, I think this is a glitch. For some reason it looks like it's already selected, but don't be deceived, it is not. So clicking on that now makes it a multi-line list, and you can tell that because a multi-line list has a tree structure, a folder structure at the top. We're going to plug that into the index, and that's going to select 3 lines, which should highlight now on the screen. That one, and that one. With a panel over here, we'll see that it has selected 3 lines. Great. I'm going to make these a dotted line though. I don't want a solid line. So choose divide length. Plug in the Brep edges to the curve input, and let's just say we split them into 25 parts. You can see that's blown up everything. Great. And then I'm going to partition. No, I'm not going to partition. Whoops. I am going to dispatch every other point. So that's divided up each line into points here. And that's going to be the list. And the pattern, we can actually just write that pattern in. I want to say true and then false. Remember, we have to right click and make this a multi-line list again here. Plug that into the pattern. And what we've got is 2 lists. We've got index 0, 2, 4, 6, and index 1, 3, 5. So if we get the line between 2 points tool and plug in A to B, that will give us a dashed line. We can hide everything else now because we don't need to see that. And look at that, we've got a dashed line. Plug in a preview, custom preview. And color swatch. I'm going to choose something that I feel like is a nice color for a bounding box. Yeah, that was good. And then I'm going to hide the actual line so that we get this color showing through. Right, so now we want to add dimensions to all of this. Let's measure the length of these 3 curves. So type in length and feed the 3 curves that we have singled out here. I'm going to round them because we don't actually need multiple decimal places here. I'm going to put in 0 again. And that's fine as it is. Let's concatenate that with millimeters. Okay. I'm just going to group this together to keep it distinct. Then what we want is linear dimension. This is going to be our text. So each of these lines is being measured, and I'll show you that the dimension is stored here. We've got 1.1 meters essentially, twice, and then 2 meters. I'm going to plug that into the text input for the dimension. So I've got the length of each of these lines that I want to measure, I want to dimension up, and I've got the text of each of those measurements, but I need to know where to put it. So let's get a volume command. And as I said before in previous tutorials, we also get a bonus centroid location with that, which most of the time that's what I'm interested in. I want to know where the middle of this box is, because I then want to place the text outward away from the centroid along that line edge. So we already created a midpoint. Actually, let's just go and select it. We created a curve midpoints component. You may want to go to your user area to grab this, but we're going to use it twice in this code and plug in each of the lines. So we've got 3 midpoints where we want the dimension to be. We are going to subtract curve midpoints from the centroid of the overall shape. So then we'll know the vectorial distance from the centroid. We don't want to decompose it, do we? Deconstruct vector. And then construct. Probably is worth making a component for this since it's used so often. I don't care about the Z direction at all. I just want to get the direction on plan. I want to unitize that vector. So I'm not interested in the length, it's just the direction from the centroid to wherever that dimension is. Oh dear, it's not my day, is it? Multiplication here. So I'm going to multiply the vector by 50. And this is where the dimension is going to start. I don't want the dimension to start bang on the corners of this box. I want it to start 50 millimeters away from each line, and the direction away is the direction away from that centroid that we've defined. Now I'm going to do the same thing for the measurement points, but let's choose 100 this time. So this is the length or the distance of the leaders for the dimension that we're going to have. Both of these are going to be moving, used to move something. So we'll plug the translation in, and it's actually it's the line, isn't it? It's the line that we're moving, and you've seen that appear offset. So that's where the dimension starts, and that's where the leaders start. Let's grab the endpoints for each of those, where the dimension starts. Plug in the start to A, the end to B. I could just move it up here for clarity, couldn't I? Then we want the size of the text to be 50. Make it as big or as small as you like. And then the line, dimension baseline, here we are. And you see why we've chosen those figures earlier. I will hide everything else so you see the dimensions there. Brilliant. Okay, so that is the totality of the placing of dimensions. Place dims, great, brilliant. We are done for the model graphics setting. In the next session, we'll be looking at the heads-up display. So I hope to see you there.